Hello, in this lesson, I'm going to be explaining atomic bonding. If you are a science student, a chemistry student to be precise, and this topic has been giving you issue, I expect that at the end of this lesson, you should be able to understand it properly and better. So, before I begin this topic, here are my expectations for you all. First off, I want us to know what chemical bonding is or what atomic bonding is. I want us to know or understand why elements bond together, and also the types of bonding we have, the major types of bonding we have, which I will be explaining, and then be able to predict what kind of bonding exists between elements or between a compound. For example, if I write sodium oxide, you should be able to tell without thinking so much what kind of bonding that is. If I write sodium hydrogen chloride, you should be able to tell what kind of bonding it is without thinking so much, right? Then before I continue, I would like us to subscribe or follow me at this handle. This is Facebook, Instagram, YouTube, and then at TikTok. I go by at Kenny Teach and in all. Okay, so what is chemical bonding? Chemical bonding, or let's say chemical bond, is the force of attraction that exists between elements in a compound. So, what are the major types of bonding we have? We have the first one we have ionic or electrovalent bonding. The second one we have covalent bonding. And then the last one, which I would like to also explain, is metallic bonding. But today, we're only going to be explaining electrovalent bonding or the ionic bonding. So what is ionic bonding? Ionic bonding involves the bond between metal and non-metal. So here is what happens. Metal donates electron, while non-metals accept electron. In that way, they form ionic bonding. So let's draw the electronic configuration. Let us use the electronic configuration to explain that. So in ionic bonding, for example, let's say ionic bonding between sodium, which happens to be a metal, right? And then plus what? Fluorine, which happens to be a non-metal. So I'm going to draw the electronic configuration of sodium now. This is the electronic configuration of sodium. Sodium has 11 electrons. So this is 11. So when we add it to, we have fluorine. Fluorine is 9. So we have 7 at the outermost shell. So we have 1 remaining. Now I'm going to explain. If you go back to our previous video where I explained oxidation number, this becomes very simple. So I mentioned that this element here will lose electron. That is, metals will always lose electron, or they will donate electron. And again, that is the major reason for our bonding. All elements prefer to be in a stable state, that is the octet state. That they prefer to be in a stable state in the sense that for an element to be in a stable state, they should have 8 electrons in the outermost shell or 2 electrons in the outermost shell for the for hydrogen and helium, okay, or even lithium that will also lose as well. So now, these elements would prefer to lose electron. Metals would prefer to lose electron in the outermost shell to attain that structure, to attain that state. Okay. Why non-metals will prefer to gain electron? And what is the reason? I mentioned that for this one to complete 8 here, 8 electrons, we have to add additional 7. And metals will prefer to just lose. For example, this is group 1 element. It prefers to lose 1 electron to maintain what? This inner part. Then this shell will leave. The reason is because the energy required to gain 7 electrons is far higher than the energy required to just lose this electron. So instead of gaining 7 electrons, you donate the electron just with this single electron, then and retain this one here. So therefore we have 8 electrons at the outermost shell and 10 electrons as a whole instead of 11 this time around. Now, for the sake of this guy here, which is fluorine, this is sodium, this is fluorine. For the sake of fluorine already has 7, remaining 1. It should prefer to just gain 1 than losing the entire 7. Now, if you were the one, will you prefer to gain 1 electron, or you prefer to lose 7 electrons? Of course, you won't prefer to just gain 1 to become what? Stable. So therefore, that's what this guy does. It will prefer to lose, to gain 1 electron to become stable, to maintain its state. Right? So now, if we are bonding, if these two are bonding, they form something like this. Now, we have this. Remember, this one has left already. This one has been donated to this guy. Okay? So when it has been donated to this guy, this one will then form. Let's assume this one here. This is where we have it. Okay? Okay, sorry, it has lost already, rather. Now, this one here will then form something like this. No, it was 7 here already, but this one is coming to join it. So it forms 8. So you see, we now have 8 electrons at the outermost shell, 8 electrons at the outermost shell. So this still forms what we call sodium fluoride. It's as simple as that. Very simple. So now, if we want to draw, this is sodium. Sodium lost an electron. It donated an electron. So this is how we draw it. You see, sodium plus 1 electron. It's plus 1 electron, that is 1 minus. Okay? This is how it is drawn. But for the sake of fluorine accepted. So have minus. Then to form what? Fluorine ion. I don't know if this is clear. Right? So this is how it's been drawn. So this is the essence of covalent bonding. For the sake of sodium chloride, the same thing. We have 2 8, 7. The seven, in that 7, the one electron here will join that 7 to give you 2, 8, 8. Okay? In this case here now we have 2, 8. Here we have 2, 8. If this were chlorine, it will have 2, 8, 8. So I believe this is very clear and we understand it. So this is ionic bonding. This is how it is being formed, and you will now understand why element bond, they bond to attain an octet configuration, the octet rule. Okay, if we're talking about our higher elements, but if we're talking about the likes of lithium, boron, beryllium, helium, and the rest, and hydrogen, they will also want to attain that duplet rule, because they have to lose 2, 1, or 3 electrons, as the case may be. So I believe you understand all that have been discussed. If you do not understand, do not worry. I'm going to make more video on this topic so that you'll be able to understand. And also, if you do not understand, let me know in the comment section, that I also know how I can tailor the explanation to you. Thank you. Bye.